Last episode, you stopped a runaway loop with a cycle counter, one agent that knew when to quit. But one agent only goes so far. What if a researcher gathers facts and a writer turns them into prose? In LangGraph, you don't reach for a new framework. You make a graph whose nodes are graphs and let a supervisor route between them. Here is the lie people tell about multi-agent systems, that it's some emergent swarm, agents talking by magic. It isn't. It's a directed graph. The nodes happen to be agents, the edges are handoffs. That's the whole idea. Each specialist is its own compiled subgraph with its own state, its own nodes, its own scripted model. The researcher subgraph knows how to search, the writer subgraph knows how to draft. Neither knows the other exists. They only know the shared state they read and write. Between them sits the supervisor, a single node that looks at the state and returns one word. Who goes next? Researcher, writer, or done? A conditional edge turns that word into a root. The supervisor never does the work, it only decides. So control flows, supervisor to researcher, researcher back to supervisor, supervisor to writer, writer back, supervisor to stop. 4 handoffs. Every handoff is a labeled edge. Draw those edges and you have drawn the entire run. Here's the program. We import AgentKit and LangGraph. We build 2 subgraphs, researcher and writer, each compiled from its own state graph with its own fakeless chat model script. Then a parent graph wires a supervisor node to both. The shared state carries messages, a node string the researcher fills, a draft the writer fills, and a next field the supervisor sets. Each subgraph is a node in the parent. Add node researcher, researcher graph. A graph used as a node, that's the subgraph. The supervisor reads state and pulls its next move from its own scripted model. First call returns researcher, then writer, then finish. A conditional edge maps that string straight to the next node or to end. Every time we cross from one agent to another, we log a MSG, sender, receiver turn, into the trace. The handoffs are the trace, sender, receiver, and the turn index that ordered them. We run it. The terminal prints each handoff in order, then the tallies 4 handoffs, 3 agents, supervisor dispatched twice, then reproduce, runs the whole graph a second time, and asserts the 2 traces are byte identical. The hero figure is a message graph drawn straight from those 4 MSG records, 3 circles, supervisor, researcher, writer, and 4 arrows between them, each labeled with its turn index. No hand-placed arrows, the trace places them. Multi-agent isn't magic, it's a graph whose nodes are themselves graphs, with handoffs as edges. The supervisor decides one node at a time. Next, we keep the graph but drop the dispatcher. With send, one node fans out to many copies at once, then fans back in. Map reduce, the LangGraph way.